Junior designers, welcome back for our next session on the power tools for DFMEA. This is our session where we talk about modeling the function and flow before the form. So quick review from last time. This is all the way over on the left side of the form, where the first column on the left would be the part, the column next to it is the function. So usually when people execute this process, they start by thinking about what part is in the system, what function does it perform. What we're going to talk about here is how you can get some additional insight if you think about the function before you think about the part that performs it. I'll spend just a bit of time on this. When we talk about modeling function and flow and how that applies to DFMEA, although this was a lot of material that I worked on, particularly in my time at General Motors, we did not invent it there. These ideas have been around for a long time, and I wanted to acknowledge the people who shared this material with me. I was involved with them in some of the research on developing these methods, but I sought them out because they were farther ahead than I was, and they really deserve a lot of the credit for what you're about to see. So going through them in a somewhat designed order, Rob Stone and Dan McAdams at that time were at the University of Missouri-Rolla starting this work. Robert Noggle, who's listed next, was an intern at General Motors when I was there and did a lot of the formative work on these techniques. Also, to this day, we're still publishing some of our results about how to use these function-based methods in failure analysis. Katie Grantham was a graduate student in the lab at University of Missouri-Rolla at that time, now Missouri S&T, who did a lot of work specifically on applying the function-based methods to performing a design failure modes effects analysis. And going down to the next row, Arem Toomer at that time was at the NASA Ames Research Labs and was sponsoring this work, and that was almost 20 years ago. So she was really ahead of her time with this idea of learning how to apply these methods to accelerate the DFMEA process. So shout out to Arem Toomer. Also, Ryan Hutchison and Matt Bohm at that time were graduate students under Dr. Stone and McAdams, and were the first two students that were working on the research grants that we had conducted in this area at GM. And it's really gratifying now to look back to see that four of the graduate students that worked on this work have all continued on in academia. That is unusual. That is an exceptionally strong performance for that many of the students to become established in teaching roles. And it is also interesting that everybody you see on this page who worked on this work has ended up in a role teaching about how to design things, and now that includes me. So a lot of my motivation to seek the job I currently have is because the way that these people have influenced my lives. So depending on how you look at this, you either have them to thank for me ending up at Baylor and teaching engineering design, or you could say it's all their fault. A little humor there. So what is a functional model? The idea here is that before you choose parts, before you start drawing, you describe the design with words. And the functional model is a description, a verbal description of the operations a product performs on input flows to transport them to, or transform them to the desired output flows. Functions are always expressed in a verb-noun pair. The verb is the function and the noun is the flow. That's what differentiates this particular functional modeling method from some others. You might also see one called the Functional Analysis System Technique, or FAST diagram. They also recommend modeling function as a verb-noun pair, but they're not as specific on this point that the noun is always a flow. It represents something that is flowing through your system, and the verb is a function that is performed specifically on that flow. So that's the technique we're going to be talking about in our lessons on this topic this week. This is the 5-step process for functional modeling. And of these 5, for the purpose of what we're doing here, because this is a technique that you could spend weeks talking about, we're going to focus on the first 3 steps. Step 1 is identify flows that address customer needs. So the point here is that when you think about what is going into a system and what is going out, think about it from the standpoint of the user of that product. Or in other words, don't think about it purely how you think that user should be using the product, but what the user will actually do when the product is in their hands, and what will happen when you release that product into the operating environment that it's going to see. Step 2 is generating the black box model. A black box means we're viewing the system from the outside. Whatever's in it is a black box. I can't see inside, but I can see outside. And when I'm looking at it from the outside, all I see is what's going in and what's coming out on the other end. And then there's a black box. I don't know what's happening inside, but somehow the things that are going in are getting transformed into the things that are coming out on the other side. Step 3 is when we start looking at what's happening inside the black box. So a function chain would be this idea that now that I've identified a flow through the system, I start describing with words what operations are being performed on that flow. And that's what I call a function chain. Chain is linked together by that flow, and there are a number of different functions that are happening. And we use a specific set of words in this technique called the functional basis. What we really want to stress in this lesson is that the functional basis is here to help you. When you're trying to think of what these verb-noun pairs are, it's probably the first time you've done this, and it is a thought process that takes a while to become comfortable with. How do I describe an engineering system with verb-noun pairs? Functional basis is a structured list of verbs and nouns that you can use. It has a lot of power if you stick to it rigidly and you use it a lot. It's really beyond the scope of what we're going to talk about here. For the purpose of what we're doing in DFMEA, what I'm going to show is that you can use the functional basis as a way of directing your thinking to identify functions and flows that you might not normally think about if you were just thinking first about the parts in the system. So the functional basis is here to help with that. Let's look at a black box diagram. In the center, you can see the black box. There will be a label that explains the overall function of the system. That would be a verb-noun pair. It's helpful exercise. What we're really focused on here is the flows that are going through. There are 3 primary classes of flows. And this functional basis is structured around these. You'll see when we look at the flow terms. 3 fundamental types of flows: material, energy, and signal. We'll talk more when we get into the functional basis about exactly what the distinctions are for the material, energy, and signal flows. But I will show one example before we wrap up this module and move into an entirely different discussion about the content of the functional basis. Here's an example. This was actually done early on by some of the students who were working on educational materials to show automotive engineers how this technique would apply to their work. So in this case, we're looking at a vehicle braking system. That's what's in the black box. Some kind of system that's going to stop the car. At this point, we don't know what's in there. Something is in there making this happen. We know what's coming in and we know what's going out. So when you look at the top with the heavy solid line, those are the material flows. And you can see there's a combination of different types of materials. You got a foot, that's part of the user. So what we're saying is that while this system is functioning, from the perspective of this system, the user's foot will enter and then it'll exit at the end. There's also a physical interface with the wheel of the car. The wheel must be able to enter that system, and the wheel must be also able to exit. In this model, we're showing that brake fluid goes in the system and never comes out. as long as we're considering a sealed system where the brake system would not need to be serviced, that's a valid job. That may sound sillier than it actually is. There has been some talk in the past about designing sealed systems that would never need maintenance. And then the upright is also a structural component in the vehicle. So you can see these flows are a combination of the user, other parts of the system that are mating with this, things that need to go in to be used by the system. Fuel might be another example in a different system. These could also be environmental factors. So it's not shown here, but water from the road could also be shown as a material that's entering the system. We're showing energy flows. So there are two primary energy flows. You can see one is a human energy. That's the energy that the human is inputting into the system. Rotational energy represents the spinning of the wheel. So that enters the system, and on the other side you can see the thermal energy is what's flowing out. So leading ahead just a bit, the plan here is to take the rotational energy from the wheel and convert it into thermal energy. That's a conventional braking system. On a hybrid vehicle, you might use different technology and say, my plan is I'm going to take the rotational energy of the wheel and convert it to electrical energy with a generator. That's another approach. That's the idea, is that there are energies flowing in, and there can be a transformation so that something different comes out on the other side. And then finally, in the signal flow, you'll see that driver input and driver feel are represented as signals. So there's something happening here with the driver's foot. It is putting both an energy and a signal into the system. There's a certain amount of energy that's used just to apply the brake pedal, and that might be necessary for the function of the system. But then that is also a signal within the system that represents it's time to actuate the brake. Feel is also a signal that's transmitted back to the driver through the foot. There's some kind of a feedback that is not just a force that would be a form of energy that could be felt, but it's also some kind of information flow back to the driver. So that's a distinction when you're making this kinds of model. There can be a phenomenon that happens, like pressing the brake pedal with your foot, that provides both energy and some kind of source of information. Think of these signal flows as information that may or may not have an accompanying flow of material energy. So that's how black box model works. Black box model you've just seen is modeled purely with the functional basis. Next lesson we'll perform will be walking through the functional basis so that you'll know what is available to you and how to use it. And that will conclude our session for this first module on modeling flow and function before form. We'll pick up with the other topics next time in the second module. Thanks for your attention. One more. See you soon.